Well, thanks everyone. It's a real treat to have the opportunity to provide this presentation today. The outline of the presentation, just a quick introduction of some of the key features of Rodel. Then we'll get into the basis of Rodel, which covers in brief the research behind it, providing an understanding of what's under the hood and why that's important to understand. Then we'll talk about the transferability and validation of Rodel. Are these UK capacity prediction equations transferable to the US and or other countries? We'll have a quick look at some of the comparisons of Rodel's capacity predictions to US field data and work that's been ongoing in that respect. Then we'll get into the program and look at the inputs and the outputs, learn how to drive the program, review the key features of the user interface, and some of its other capabilities as well. And time permitting, we'll do a quick, we'll open it up and do a demo of the program. Introduction, Rodel is a program that has an analysis process that facilitates the convergence of design solutions to meet operational objectives. It allows for the exploration and identification of viable alternatives for your given peak hour flows, your site constraints, and your project objectives. It's particularly well suited for constrained high flow locations. It allows for the analysis of flared entries, corridors, and it works well for many other applications as well. It was originally released in 1986 in the UK. It's been used by many agencies and consultancies across the US since about 1992. There was a major update in 2012, bringing the old DOS-based Rodel into the current Windows program. It's been had some major upgrades to include conformance with North American design and analysis practices, such as right-hand drive, English units, US peak hour factor. It includes now a print selection menu for documentation. Importantly, it has maintained its interactive user interface, which is part and parcel to Rodel. It includes two capacity models. It includes the empirical model, which we will talk about a little bit later. It has extended the application of the empirical model to include lane inputs to determine effective geometry, which we will also discuss in more detail. It fully integrates the 2010 HCM capacity model. It provides identical results to HCS. It will include any future updates to that model as well. It now includes full right turn bypass modeling, full right turn lanes, or partial or yield right turn lanes. It has 4 different types of right turn modeling. It now includes the crash prediction models and as well economic analysis to include US and UK intersection and approach level crash prediction methodologies. So your crash and your delay costs are derived from user input values for each. So you choose a specific crash model, you put in the costs, cost per type of crash and or user cost with respect to delay, and it calculates that for you. So the Rodel's interface was developed to facilitate understanding of the analysis and to assist in the exploration of the design envelope to arrive at solutions. The inputs and outputs are explicit numerical values. There's no unknown factors. It's designed to inform the analysis or the designer of the geometric and operational interrelationships. It provides interactive and an educational user interface with its pop-up help as well as the embedded user manual. The interface includes easy sensitivity testing to do what-if scenarios, you can increase or decrease your percentage of traffic for specific approaches, to allow for testing of the robustness of a design. You can test with reduced capacity, perhaps due to contextual issues like on-street parking near the roundabout or other environmental constraints. This can allow you to assess the potential for unacceptable queues or delays on specific legs, allow you to then evaluate and adjust geometry to bring those to acceptable levels. And this is completed with the user interface, which allows you to view the input and the output simultaneously. It has 2 primary modes: a traffic planning mode, which allows the user to specify a target parameter such as delay or a queue or your VC ratio, and then it will give you sets of geometric parameters to meet that targeted user specified parameter, which I used to use a lot, when I was an early user of Rodel, and as you get more comfortable with it, I find myself using it less. However, occasionally it comes in very handy, and there's probably applications out there that others could benefit from in respect to that. Most of the time I'm in the full geometric analysis mode, which is includes, so when you're in the traffic planning mode, then you would then move to the full geometric mode to then refine your geometry, include your bypass modeling, your pedestrian capacity effects. So in some sense, the traffic planning mode has been described as, from a golf analogy, of sort of the drive off the tee, and then the full geometric mode is the chipping and putting. It's fully HCM compliant. HCM and Rodel both utilize what's called time-dependent queuing theory, as developed by a U.S. researcher long ago. Delay is derived from the queuing theory equations. Therefore, nothing in this respect is different from HCM to Rodel. However, Rodel incorporates what's known as high-definition queuing theory equations via time slices. These adjust for varying VC ratios, and the importance of this is that Rodel provides stability over the entire range of VC ratios, even ratios exceeding 1, which provides accurate operational predictions at higher VC ratio conditions. And again, in high-flow constrained conditions, that's important. HCM implements a more simplified version of this, and its stability is stable up to about 0.9 VC ratio. So Rodel can be used for analyzing all types of roundabouts, from small urban compact with very perpendicular entries, small entry widths, and it'll account for the capacity effects of that type of a shape, and then it can also account for the operational output and prediction for a larger curvilinear type of design. Moving to more multi-lane, again, you can have a wide variation in application types with single, multi-lanes, various types of right turn bypass lanes, in hybrids, turbos. So Rodel will capture the operations of these various types of roundabouts, and again, giving you a high level of confidence in the traffic operations side and the predictions of what you're doing. So just a few quick examples, the inputs that you put into Rodel. Here's a single lane, so you'll be identifying a single lane approach, a single lane entry, single lane circulating, and a single lane exit on this type of a roundabout. And in this type of roundabout, you'll also be identifying a single lane roundabout, but you'll put in a full right turn bypass lane, and in this approach, a partial or yield right turn bypass lane. And then you can analyze roundabouts in series, and these two roundabouts represent most of the variation in roundabout design, which is to say 2-lane entries fed by 2-lane approaches, flared entries, single-lane entries, all contained within spirals within these two roundabouts. Yield right turn bypass lanes and full bypass lanes. This is a 3-lane entry, with a full right turn bypass lane. Rodel can model up to 4 lanes of entry, which is rare, but occasionally occurs. And here's a flared approach. So your approach roadway width V, your entry width E, your distance over which you're flaring. You're going to identify a 2-lane circulating and a 2-lane exit as well. And if you don't identify these correctly, we'll talk about this in a moment, Rodel gives you error messages within its pop-ups, and it doesn't allow you to make the mistakes that were occurring with the previous DOS version occasionally.